All right, so here's this next question, and the question says that the diagram shows a picture hanging symmetrically by two cords from a nail fixed to a wall. The picture is in equilibrium. Picture is in equilibrium. Explain what is meant by equilibrium. So the all-time favorite question, equilibrium of forces is what? Equilibrium is what? When the sum of all forces is zero and when the sum of all moments is zero, right? So forces zero, moments zero, and definitely you will have to mention that the sum of moments and sum of forces is zero. All right, then the question says draw a vector diagram to represent the three forces acting on the picture in the vertical plane. Label each of the forces clearly with its name and show the direction of each force with an arrow. So you need to make a vector diagram to represent three forces. Okay, now remember that when I'm making a vector diagram, I know that there's this one force which we call the tension, and remember tension always acts away from the hanging object. So this is the direction of tension, this is the direction of tension, and definitely this picture has its center of gravity and all its weight is going to be acting along the center of gravity. So this is the weight. So we have three forces, this tension, and then this weight. I'll just trace these forces. This is one force acting like this. This is the next force acting like this, and then this is the third force acting downward, right? So I'll just copy each one of them one by one. I'll copy this force first and I'll just paste it. So this force is copied and pasted. Now I'll copy the next force and I'll make sure that I paste it such that this new force that I'm connecting with the previous force is in such a way that the previous force head joins the tail of this new force, right? So I join them head to tail. You can see they are joined head to tail at this point. Now I'll pick the third force and I'll connect that. Again, I'll make sure that this third force that I join is such that it joins with the tail of the first one, with the head of the first one, right? So this is the head of the first one and I simply join this head to tail. So what do you see? You see that these three forces make a closed loop, make a closed triangle. I started from here, went this way, all the way like this. I see a closed loop, and a closed loop shows that it's equilibrium of forces. The resultant force is zero. Each of them, this is the tension force, I had to label them. This is the tension force, I had to label this, and this is the weight, I had to label this as well. All right, so if you want me to make it here, this is how the diagram would look like. This is one force, this is the second force, both of them are tensions, and then the last one is this one. Right, so tension, and weight. All right, the tension in the cord is 45 newtons and the angle that each end of the cord makes with the horizontal is 50 degrees. The vertical component of the tension in the cord, we have to calculate that. So this tension force makes an angle of 50 with this horizontal. That means this will be the horizontal component, this will be the vertical component. Horizontal is once again cos because it's along the angle, so cos theta, t cos 50, and then this is t sine 50. Similarly, this would be the vertical component, this would be the horizontal component, right? So this is once again t cos 50 and this is t sine 50. All right, what I need to find? I need to find the vertical component of the tension in the cord. So vertical component of tension in the cord means what? Yes, tension is given to us as 45 newtons. So vertical component is what? Vertical component is t sine 50. So c1 vertical component component is equals to t sine 50, and I know that t is 45 newtons, so it's 45 sine 50. You will calculate that and you will get your answer as